Welcome back, everybody. In this video, we're going to do the last example from section 2.3. So let's get started. So the story here is a weight of a newborn baby is 7.5 pounds, and we're told the baby gained a half a pound a month for its first year. So we have 6 questions to answer regarding this. So first of all, in 19, it says find a linear function that models the baby's weight W as a function of the age of the baby in months T. So the input is T, the output, we'll call that W of T. So we're told that the newborn weight is 7.5 pounds. So after no months have gone by, it's 7.5 pounds. The baby gained half a pound a month for its first year. So after 1 month, it'll be 8 pounds. After 2 months, 8.5 pounds, and so on. So the graph, which we'll need to do here in a bit, the horizontal axis is going to be time. The vertical axis will be the weight as a function of time. When the time is 0, we know the y-intercept is going to be 7.5. And so to write down the formula, then we just need the slope. But we're told that the baby gains 1/2 pound per month in its first year. So the vertical axis is weight in pounds, the horizontal axis is in months. So that 1/2 pound per month is going to be the rate of change in the baby's weight, so the slope. So we have W of T. That will be 1/2 pound per month plus the 7.5 pounds the baby weight in the first place. Okay. All right, so there's our W of T. For 20, we want a reasonable domain and range for the function W. So the scope of the problem, it says for the first year, the baby's growth rate might be different after that first year. So for the domain, I would just say that T is 0 to 12. Okay. Because they only tell us that 1/2 pound a month applies really for the first year, so up until 12 months. All right, so then for the range, W of T, we know the minimum is 7.5 pounds. And then if the baby is going to gain a 1/2 pound every month, that means it would gain 1 pound every 2 months. And so in 12 months, it will gain 6 pounds. 7.5 pounds plus 6 pounds is 13.5 pounds. Okay, so if you didn't quite follow that also, as you know, you could find W of 12 to find the baby's weight at 1 year old. That will be a 1/2 pound times 12 months plus the 7.5 pounds initially, and that gives you 13.5 pounds. Okay. So then that takes care of that. For 21, it says if the function W is graphed, find and interpret the X and Y intercepts. So the Y-intercept was 0, 7.5, and the 7.5 pounds is the weight at birth. Okay, and then there is no x-intercept, right? So if there were an x-intercept, it would be, okay, the baby's weight is 0 sometime before they were born. But the model here, we're only applying, I think, after birth time. So there's no x-intercept in the domain. Okay, if the function W is graphed, find and interpret the slope of the function. That was the 7.5. No, the 1/2 pound per month growth rate. And then 2 more. When did the baby weigh 10.5 pounds or 10.4 pounds? So let's get that. So we're given the function. We want to know a time when we'll have a weight of 10.4 pounds. Okay, so we'll start by subtracting the 7.5 pounds. So that's 10.4 minus 7.5, that's 2.9. And then lastly, we'll divide by 0.5. And that's 5.8. So 5.8 months. So just under 6 months old is when the baby will weigh 10.4 pounds. Then what is the output when the input is 6.2? So that will be 0.5 times 6.2 plus the 7.5. We'll calculate that and then interpret the answer. So that's 10.6. And that will be pounds at that time. All right, so that's the end of this example. Essentially, we were given a story and it led to a linear function. We figured out what the formula for that linear function was and then answered a couple of questions based on it. A little bit about domain and range, a little bit about intercepts, and then given a y value, what's the x value, and then given an x value, what's the y value. So that finally will finish section 2.3 for us. Let me know if you have any questions and have a great day.